Anyone required to operate forklifts must be trained in a wide variety of topics, including engineering principles, forklift operating rules, equipment characteristics, environmental hazards, operator maintenance, hazardous locations, surface operating conditions, site-specific operations, potential hazards, and other information. This program cannot cover all aspects of the required training because new government standards require employers to make the training site-specific for your workplace and the potential hazards that may exist in your company or area of operations. Training should include three distinct methodologies. First, there's academic or classroom training. This program covers the majority of the required classroom training, but your company amplifies this training by making your training site-specific to your operations. Next, operators must be provided hands-on training to ensure operators fully understand controls, equipment performance, individual characteristics of each forklift equipment they will be operating, and the potential hazards that may be encountered in your work area or organization. The third method of training is evaluation. Through the evaluation process, operators can learn from mistakes and improve their performance. An evaluation means an experienced person, such as a trainer or supervisor, who has the knowledge, training, and experience to train and evaluate operators' competency in forklift operations. The evaluator observes individuals who operate forklifts to determine their safe operation of the vehicle, how the operator observes safety rules, and how the operator knows, understands, and handles the equipment. The four primary topics or areas to be covered in the training program must include: number one, the general hazards that apply to the operation of all or most powered industrial trucks. Two, the hazards associated with the operation of particular types of trucks. Three, the hazards of workplaces generally. And four, the hazards of the particular workplace where the forklift is operated, also called site-specific training. The purpose of this type of training is to make sure potential hazards in each specific location or workplace are identified, and forklift operators are more aware of the specific potential hazards. The new rule states, the training program shall be presented to all new operators regardless of previous experience. That's fairly clear. All new operators must be trained regardless of their experience. To avoid duplication of training, the new rule also states, an employee who has received training and been found by an evaluation to be competent to perform the duties of an operator safely does not have to be retrained at specific intervals. However, all new operators must have their performance evaluated. If an operator has previously received training in a topic required by the rules, and such training is appropriate to the truck and working conditions encountered, additional training in that topic is not required if the operator has been evaluated and found competent to operate the truck safely. How that person's competency is evaluated is up to the company. This can be through testing and examination, performance evaluation, or other means of evaluating the level of previous training. All forklift operators must be evaluated at least every 3 years. Certification. Certification of training and competency must be documented for all persons who operate powered industrial equipment. This certification must contain the name of the operator, the date of training, the date of the evaluation, and the identity of the person or persons performing the training or evaluation. Documentation is extremely important for a variety of reasons. Therefore, each company should maintain records of what training was conducted, who conducted the training, who was trained, when operators were trained, and what was included in the evaluation or performance testing. We cannot stress enough that proper training documentation be maintained of all forklift operators. Government rules do not require forklift operators' licenses, but many companies have found them useful and helps reduce unauthorized use of forklifts by uncertified persons. General types of equipment. As we stated earlier, there is a wide range of equipment, each designed for specific industries and uses. Manufacturers classify powered industrial trucks according to each truck's individual characteristics. There are 7 classes of trucks. Class 1. These are electric motor, sit-down rider, counterbalance trucks, and they use either pneumatic or solid tires. Class 2. Electric motor narrow aisle trucks that use only solid tires. Class 3. Electric motor hand or hand rider trucks that use solid tires. These are commonly referred to as electric pallet jacks. Class 4. Internal combustion engine trucks using solid tires. These are the most common types of forklifts. They can be gas, diesel, or propane powered. Class 5. Internal combustion engine trucks using pneumatic tires. Class 6. Electric and internal combustion engine tractors with pneumatic tires. Class 7. Rough terrain forklift trucks which use pneumatic tires. These are more commonly used in construction. Each of the different types of powered industrial trucks has unique characteristics and inherent hazards. To be most effective, training must address the unique characteristics of the type of vehicle operators are being trained to operate. Before we move on, let's take a quick look at solid and pneumatic tires. Pneumatic tires are tires filled with air, just like your automobile tire. They are designed so the forklift can maneuver in uneven, ungraded terrain surfaces. The tires are more flexible and can adjust to the changing surfaces on which they drive. Solid tires are exactly what their name implies. They are made of solid rubber or other materials. These tires must be used on smooth, fairly even surfaces. Solid tires are not flexible, but provide excellent wear. However, they can be cut or damaged. When solid tires must be replaced, it requires the use of a high-pressure press, which presses the tire onto the forklift wheel. Technicians with proper equipment perform the demounting and mounting of solid tires. Engineering principles. Perhaps one of the most important yet misunderstood parts of any forklift training program is the engineering principles of the equipment. Unless you have this knowledge, it's difficult to understand some of the safety rules relating to forklift operations, and certainly detracts from your ability to make good judgments when lifting odd-sized and difficult loads. This program focuses on some basic principles, but they are a very necessary part of professional forklift training and operations. You should learn these basic principles, and if you are unclear or have any questions, please ask your supervisor or trainer to explain them more fully and answer your questions. Automobiles and forklifts. Is there any difference in operating or driving an automobile and a forklift? Absolutely. An automobile is steered by turning the steering wheel, which in turn moves the front wheels and tires in the direction in which you're steering. The front tires turn and move the automobile in the direction you want to turn or travel. Forklift steering is just the opposite. When you turn the steering wheel, the rear tires move to change direction. Forklift steering is totally different than steering an automobile, which is why you need training and experience to understand these differences. Automobiles and forklifts both generally use hydraulic braking systems. When you step on an automobile brake, hydraulic fluid is compressed through the master cylinder to wheel cylinders, which apply force to the brakes to stop the vehicle. Forklifts with hydraulic brakes operate basically the same way. However, only certain battery-operated forklifts, such as large sit-down units, use hydraulic brakes. Others may employ mechanical systems actuated by electronic solenoids, such as order selectors. Still others, similar to walkie pallet trucks, have mechanical systems. On many electric trucks, when an operator removes his or her foot off the electric forklift accelerator or standing pad, friction stops the electric forklift. It's a different sensation, and stopping distances are somewhat different, again pointing to the need for training and getting used to the different type of equipment. An engine must power forklifts, just as an automobile must be powered. Some forklifts use combustion engines, which use gasoline, diesel, propane, or they can be powered by electrical motors. Propane forklifts are used more often, particularly in warehouses and inside areas. The fuel is cleaner. However, propane does emit carbon monoxide and is a highly flammable gas. Another difference between automobiles and forklifts is that forklifts do not have shock absorbers. An automobile uses shock absorbers or struts to keep the tires firmly on the road surface while the vehicle is in motion, which reduces bouncing of the tires. Automobiles also have a 4-point suspension system. This means the automobile is supported by 4 points of a suspension system. Forklift engineers have designed forklifts on a 3-point suspension system, even if the forklift has 3 or 4 wheels. Since forklifts don't have shock absorbers, a pivot pin in the center of the axle supports the forklift's rear end. This allows for the up and down movement of the rear tires when traveling over bumps and uneven surfaces. The pivot point and the front tires make up the 3-point suspension system. The truck's steer axle is attached to the truck by a pivot pin in the axle's center. This 3-point suspension system forms an imaginary triangle called the stability triangle. The technical definition of the stability triangle is when the vehicle's line of action, or load center, falls within the stability triangle, the vehicle is stable and will not tip over. However, when the vehicle's line of action, or the vehicle and load combination, falls outside the stability triangle, the vehicle is unstable and may tip over. When the combined center of gravity of the truck and load move outside the lines of this triangle, the forklift will overturn. There are many situations in which this can occur. Fast, sharp turns can cause the center of gravity to shift outside the triangle. Lifting a heavy load and tilting the mast forward or backward while moving. Having a heavy load lifted, then running over a piece of wood or other uneven surface can cause a shift in the center of gravity and overturn the vehicle. Fulcrum principle. Let's begin with the lever principle, specifically the fulcrum principle. Technically, the fulcrum is truck's axis of rotation when it tips over. Simply stated, you have 2 weights balanced on a fulcrum like a playground seesaw. On the forklift, 1 weight is the heavy rear end or counterweight and the weight of the truck. The fulcrum point in this case is your front tires, and the other weight is the load you're carrying. The counterweight balances the load with the front tires as the fulcrum point. The counterweight is the heavy metal part of the forklift that compensates for loads and determines the proper safe lifting capacities. Never add a different or additional counterbalance to any forklift without the manufacturer's approval. By modifying the forklift, you may have significantly changed a variety of important engineering principles such as center of gravity, safe lifting capacity, maximum load height, or other unsafe conditions. One of the most important safety considerations when operating forklifts and raising loads is never tilt raised loads forward, except when the load is in a deposit position over a rack or stack. When stacking or tiering, only enough backward tilt to stabilize the load is to be used. We'll discuss raised loads more in a few minutes.